In this video, we are going to take a look at Unit 8, Lesson 2, which is playing with probability. In this lesson, by the end of this lesson, you'll be able to estimate the probability of an event and determine probability of events given a word. So go ahead and read the scenario on page 263 in your workbook to see what you would have done if you did this lesson in class. And then I'm going to give you enough information in this video so that you can complete this lesson. All right, so what page 263 told you that you're going to be what you would have done in class is that you would have gotten a bag. Okay, this bag has a bunch of slips of paper in it with names on it. You'd shake the bag, draw a slip of paper, write down the name, and then return it into the bag, shake it up again, draw another one, and continue doing this until you have recorded 15 names. So I've done this for you, and here are the 15 names that came up when I drew them. So go ahead, pause the video and write these at the bottom of page 263 because you're going to need to use these. All right, so which name was drawn most frequently? So in our case, it was Lynn. So Lynn's name was drawn most frequently. What was the relative frequency of the name that we drew? So we drew Lynn's name. We drew it 6 times out of our 15 times that we drew. And so what's kind of our estimated probability there? So 6 is a little bit less than half. So half of 15 would be 7.5. So we drew Lynn's name about half the times, a little bit less. All right, so now we are going to use that data. So now you have those names. And so I want you to go and pause the video and work on page 264 to answer the 4 questions there about the names that we drew, and then come back to the video. All right, so based on the data that you collected or that I gave you in this video, estimate the probability of drawing each of the names from your bag and explain or show your reasoning. So we drew Claire's name 4 times out of 15. So we would estimate that the probability of drawing her name would be 4 out of 15. And so divide that in your calculator and you can grab the decimal. So 4 out of 15 is about a 0.27 probability, which is a 27% chance. Lynn, we drew 6 times out of 15. And 6 divided by 15 is 0.4. So the probability we're estimating based on our results is that it would be a 0.4 chance for her, which is 40%. Priya, we did not draw at all. So we would say there's a 0. It seems like there's a 0% chance. 0% chance for Elena. We drew Jada's name 5 times out of 15. And 5 divided by 15 is 0.33. So it appears that there's a 33% chance to draw Jada's name. We did not draw Han or Andre or Diego or Noah. So it appears that there's a 0% chance that we would draw those based on our results. And so there's actually, if they tell you there's actually 15 slips of paper in this bag. So what names do you think are written on all of the papers? And explain your reasoning. So we drew 15 slips. And so it would make sense. It would probably make some sense that we think those are the names, that Claire is on 4 of them. that Lynn was on 6 of them and that Jada was on 5. So that's one option. Maybe you think it's a little bit different, but we drew 15 names. That's what, or 15 slips. That's what came out. So it would make some sense for us to think that. If you were allowed to keep going and around the group drawing names and replacing them until you had 100 names, how do you think that affects your understanding of what's in the bag? So here we've only drawn 15 and there's 15 slips. So in order for us to know that these actually are the number of people's names in the bag, we would have had to have drawn basically each name once, okay? And the likelihood of that happening is pretty low. But if we drew out 100 names, it would keep showing us more and more about the actual names. We would get more data about what is in the bag. And we would get closer and closer to being able to identify based on these probabilities whose names are actually in the bag and how many times. So we just get closer and closer estimates. So now this bag was actually slips of paper that a teacher put in. And so the next month, the bag is going to contain 15 slips as well. And this time included in the bag is Lynn's name 5 times. So Lynn is going to be in there 5 times. Claire is going to be in there 4 times. Han is going to be in there 3 times. Diego is in there twice, and Jada is in there once. The teacher draws names one at a time, replacing them. What might the teacher's list of names drawn look like if she draws 10 times? Is this the only list possible? So make up your own list. I mean, it's random, so it could contain Jada's name 10 times. Okay, that's a chance because she's in there once. It certainly could not include Noah. Okay, so Noah would not make the list because he's not in the bag. As you're making your list, it would make sense that Lynn would probably be in there more than Jada because Lynn's in there 5 times versus Jada once. And you could have a lot of different possibilities. So what you come up with definitely is not the only list possible. So maybe you said Lynn was going to be chosen 3 times, Han chosen twice, Diego once, or maybe Diego's getting chosen twice, Jada again. So what's that? 3, 6, 7, 8, and we needed 2 more. Claire. Maybe Claire was in there twice. Okay, so that's one possibility. Definitely not the only one. All right, so here are the actual bags that were possibilities. Okay, so what we drew from, okay, so the names that I drew from came from one of these bags. And which bag do you think that we had based on the names that we saw? And so we definitely saw a Claire, so it can't be this one. Okay, it can't be this one, and it can't be this one because Claire was in our list. We also saw Lynn and Jada. Okay, so it makes sense that it was one of these 2 bags. And so which one do you think it was? Since we had Claire 4 times, Jada 5 times, and Lynn 6 times. So they're all pretty close to each other. We got 4, 5, and 6. And so these are, Jada and Lynn are significantly less than Claire in this one. So I would think it maybe came from this one, just for those being closer. One other thing I want you to look at here is that we can write shorthand for probability. So if I say the probability of drawing Claire, okay, when we're writing that out, we could just write probability of Claire. So this bag that I chose, what is the probability of Claire being drawn? Well, Claire is in there 3 times out of 15 slips. And so we just put this big P with the parenthesis. So if we wanted to do the probability of Lynn, we could write it like this. And the probability of Lynn in that bag is 5 out of 15. And we could do probability of Jada and say that that is 7 out of 15. All right, so are you sure which bag you have? So we're not 100% sure, right? There were 2 bags that had those 3 names. What we are sure of is that it was not bag 2, 3, or 5. Okay, because you absolutely 100% could not draw a Jada out of any of those bags. So it certainly cannot be those. If we had drawn Noah, we would know it was bag 3 because Noah is only in bag 3. But other than that, we're not really sure. Would drawing slips out of the bag 100 times make you more sure? And so certainly it would make us more sure, because if Claire started showing up a lot versus Jada and Lynn, we would think maybe it's bag 4. If they keep being where Jada and Lynn are relatively close and Claire is about half of Jada, then we're pretty sure that bag 1 would be the option. So as we do this experiment more and more times, it reveals closer and closer to the expected probability. Do you think your list of, and we did 15 names from question 1, matches the 15 names created by other people in the class? So again, different lists, right? So bag 1 and bag 4 would be very similar to each other as far as names. Bag 2 is Andre, Diego, and Elena. That's similar to bag 5. But bag 3 is the only one with Noah. So those two, so bag 1 and 3 going to be kind of similar. Bag 2 and 5 going to be similar as far as the names. And then bag 3 significantly different. For question 4, is it possible for the teacher to draw Jada's name twice if she only draws 10 times? So certainly you can draw Jada twice. Okay, that doesn't matter. Or maybe it says this is probably supposed to be for bag 4. For bag 4. And it's certainly possible. Absolutely, you could draw her name twice. Can you draw her name twice from bag 3? No. Even though she's only in bag 4 twice, she's there. So could we draw her? Yes. Could we draw her twice? Absolutely. All right, then let's get into looking at some different words. So we're going to be using the American alphabet in this. So let's talk about it a little bit just to make sure that we understand. So how many total letters are there in the American alphabet? So there are 26 letters, A to Z. How many of them are vowels? So we have 5 vowels. Remember that those vowels are A, E, I, O, and U. And then the other 21 letters are considered consonants. So if we're talking about vowels, it's these 5 specifically. Consonants, the other 21 letters. And if we're just talking about letters in general, all the letters A through Z. So in the word math, okay, and here's that shorthand that we're seeing. So this means probability that an M is chosen. So what is the probability that if you selected one of these at random, that you would have selected the letter M? And so that there's 1 M up there out of 4 total letters. So the probability would be a 1 in 4 chance. As a decimal, that's 0.25. As a percent, that's 25%. How about the probability of a consonant? Okay, so A is a vowel, so that one doesn't count. So there are 3 consonants up there out of the 4 letters. So the chance that the letter we chose is a consonant is 3 in 4, which as a decimal is 0.75 or 75%. So go ahead and try this one, finding the 3 probabilities listed there. Pause the video and come back. So the probability of an A, now we have 5 letters in our sample space. One of them is an A out of the 5. So it'd be a 1 in 5 chance. which would be a 0.2 decimal or a 20% chance. Vowel. So I and A are both vowels. So we have 2 options up there out of 5 that would be considered vowels. And 2 out of 5 as a decimal is 0.4 or 40%. Probability of a Z, there are 2 Z's out of our 5, so 2 out of 5. So again, a 0.4 chance or 40%. All right, so let's practice what's going to happen in the book next so that you understand what we're wanting here. So in the book, what we're going to be doing is trying to come up with some words that have these probabilities. Okay, so let's come up with a word that the probability of an O is a 1 out of 4 chance. So what this is telling me is I could write out a word that has 4 letters in it. One of them needs to be an O. So I could do road, like rode a bike, or I really could do a road like that you drive on. So each of these have 1 O out of 4 letters. So those would work for that. If you needed the probability of a vowel is 2 out of 3. So you could think of it as three letters, 2 of them needing to be vowels. So maybe pie or U. So those 2 would be options. You could also, for these, if you could get an 8-letter word with 2 O's in it, that would work as well. Because if you had 8 letters and 2 of them were O's, that would be 2 out of 8. So if you knew a word like that, 2 out of 8 would simplify to 1 out of 4. So that would be fine as well. In this next one, it says the probability of a B is 1 out of 4 and a vowel is 1 out of 2. So notice how the denominators of these are different. So this one is telling me, okay, there's going to be at least 4 letters. Okay, and B is going to be one of those 4 letters. And then it's 50% or half are vowels. So we're going to need actually 2 out of 4 letters to be vowels. Okay, and one of them to be a B. One of the other letters to be a B. So maybe book. So that has 2 vowels, which is 2 out of 4 chance, which simplifies to 1/2. And a B is 1 out of 4 letters. So that matches those probabilities. All right, so then on page 265, go ahead and try to do numbers 1 through 4, coming up with words that fit these probabilities. If you're doing it at home, you're not really going to be able to do number 5 with a partner, but you should be able to complete 1 through 4. So do that, pause the video, and then you can come back. All right, could have come up with a ton of different words for this. These are just a couple examples, but we know we need 2 consonants, 1 vowel for every 3 letters. So we could do cat, that has 2 consonants, 1 vowel. Definitely could have done dog as well. You could even have 6 letters. So if we did something like booths, this has 2 vowels out of 6, and 2 out of 6 simplifies to 1/3. And 4 consonants out of 6 simplifies to 2/3. So that would work as well. Number 2 wants kind of the opposite. 2 vowels, 1 consonant for every 3 letters. So you could have done U again. Could have done boo. Number 3, the vowel is there half the time, 0.5. Okay, so that's 1 out of 2 or 2 out of 4. And then you want a T in there, 1 out of 4. So we know we need at least 4 letters. Okay, and then half the letters need to be vowels. One of them needs to be a T. So we could have done boot would be an example. You could do sight. So half the letters are vowels. One of them is a T. Number 4, you need the S to be there half the time and the vowel to be there 25% of the time. So we need this 1/2 and this 1/4 for vowels. So you could do something. So if we had 4 letters, we need 2 of them to be S's and 1 to be a vowel. So we could do pass. Maybe you're a fisher and you like bass. Or toss. Okay, but 1/4 of the letters vowels and 2/4 of the letters are S's. All right, so see if you can do these probabilities for the word kangaroos based on what we've just talked about. All right, so the probability of a vowel here. How many vowels do we have? So we have 1, 2, 3, 4 vowels out of 1, 2, 3, 4, 5, 6, 7, 8 letters. So this simplifies to 1/2. Decimal would be 0.5. Percent would be 50%. Probability of an A. So we see 2 A's out of 8 letters still. That simplifies to 1/4, which as a decimal is 0.25 and as a percent is 25%. The probability that you choose an S or an A. So how many S's or A's are there? Well, we see 2 A's and then 1 S. So that's 2 A's and 1 S. So that's 3 out of 8. That will be quote unquote winners here. Okay, so 3 out of 8 letters, and 3 out of 8 does not simplify any further. The decimal would be 0.375, which would be 37.5%. What's the probability that it is not a K? Well, there's 1 K up here. So there are 7 other letters that are not Ks. And 7 out of 8 does not simplify. The decimal version would be 0.875, which is an 87.5% chance that you would select not a K. All right, so lesson synthesis here. I have drawn so I have a bag and I drew these letters. I drew 15 times and these are the letters that came up. Okay, so what letters are in my bag? And so you can see from there that we've got P is definitely in there, I is in there, Z is in there, A is in there for sure. What is the relative frequency of the letter Z? So that's where we count up the number of times Z showed up. So 1, 2, 3, 4, 5 times. So 5 out of 15 total draws is 0.33 as a decimal, which is 33% of the time. So based on the experiment, Z came up 33% of the time. So here's what's actually in my bag. So I had 10 slips of paper. The word pizza was in there twice. So now that you know what's in my bag, what is the probability of randomly selecting a Z? So now we see that there's 4 Z's in there. So there are 4 Z's out of 10 total letters. So the expected probability would be that we get a Z 4 out of 10 times, which is 0.4 or 40% of the time. And how often did I get it? 33% of the time. So what would we expect to happen if I continued drawing 100 times? So if I drew 100 times, we would expect to draw the number 100 40% of the time. So 40% of 100 means that you would expect to draw the letter Z 40 times. And that's what relative frequency, that's what probability does for us, is that's how many times it's expected. Okay, and then this is how many times it actually happened. So relative frequency is how many times it happened in an actual experiment. Probability is what we would expect to happen over the course of time. All right, so here is your lesson summary. Go ahead and read through that, underlining the important information. Hopefully now you can find the sample space of chance experiments. You can model situations using probability, and you can use sample space to calculate probability. You can check your understanding of this lesson by doing the lesson 2 practice problems. And remember that I have a video of me working through those practice problems if you need some extra help. And you can also check your understanding of the lesson by completing this cool down. And if you're struggling with that, you can certainly be sure to reach out to your teacher for some help.